Yeah, use.
Okay, hello everyone. Thanks for coming. My name is Anthony Vuong. I work for the Linux Development Support Group under Josh's team. My talk is adopting Kubernetes with Rancher. Yeah, so let's get started. So the goals of my presentation today are just to expose the pain points we have, share how we adopted and grew our Kubernetes knowledge, and kind of show you the planning and deployment from our first version of Rancher to the second version. And so let me talk about how we ended up with Kubernetes. We needed a solution to run containers in production. Containers were the new thing, and we had to find a way to deploy it. So my team and I we did a team analysis on whether or not we want to use Kubernetes to do this orchestration or Docker Swarm. We ended up using both. It was our first time doing containers. We knew pretty much nothing about it. And different members of the team wanted to explore different options as well. So it was kind of a wild west in our team, but it was also a time for us to learn and experiment with both technologies. What we found was that Docker Swarm is good for small and simple deployments. But when it came to adding extra features like external secrets, if we wanted to add integrated logging, it wasn't as easily you couldn't easily add it in compared to Kubernetes. There were also talks of Docker Swarm being deprecated, so that had a factor in our decision of how we ended up with Kubernetes. Also, from our experience, when we had to debug issues, there weren't many Docker Swarm forums or just community support. So whenever we looked up issues, it was difficult to resolve. But when we had issues in Kubernetes, there's a lot of GitHub issues and a lot of GitHub discussions. So it has a much larger community support base and the backing of large companies as well. So we felt comfortable sticking with Kubernetes to deploy our containers. So now that we decided on using Kubernetes, how do we manage it? Or what do we use to manage it? So we didn't want to do Kubernetes from scratch. We wanted to find products that would help us do the heavy lifting. So we're primarily hosted on-premise. So we had to look at products that allow us to run Kubernetes on-premise. So we considered the following products. At that time, we considered VMware Tanzu. It was expensive and not included with our current VMware license. I also mentioned that at that time, VMware Tanzu was really new. We did run the community edition, and it did not spin up a cluster seamlessly. It was very buggy. I don't know what the situation is now. Maybe that has changed, but that had a factor in us not going with that route. Another product we considered was Platform 9. Platform 9 is basically a hosted service that offers agents that allow you to install. If you run their agent on the VMs you create, it installs the Platform 9 can help you manage and install Kubernetes on it. It's at that time, pricing was based off resources used, which can get potentially expensive. Now they took down that price page and they just said, contact them for further information. And last but not least, we looked into Rancher, the open source version. So the open source version is fully featured. There's no paywall for any of the other, it is what you get. You don't have to pay for any additional features. We did contact Rancher for their enterprise support, which is just basically, 24/7 support if there's any issues or if you need any help. I believe there's a disclosure that we're not allowed to discuss the price, but I can tell you that it was really expensive. more than all of them that I listed. I don't recommend contacting them. Yeah, so that's how we ended up with Rancher open source. So, when we decided to go with Rancher, we created our first Rancher cluster, which I call version 1. It was not done right. We built it with static servers. So in the same way we build servers and install applications on them, we pre-built like 6 VMs, give them a static network, and kind of prep them for provisioning for Rancher. I don't want to say it's manually provisioned, but we have scripts that provision it for us. But it's a matter of cloning something, running Ansible. There wasn't a orchestration job that did it for us. It was using a legacy method of provisioning, which we do for stuff that isn't containers at this point. Again, it was also our first time using Kubernetes in production. So this is kind of a very high level workflow chart of what it's like to provision a new cluster in version 1. If you take out the Booleans, it's about 8 steps, 8 isolated steps. I did not include that sometimes you have to run it per host. So it can easily be 48 if it's 6 nodes. But this is the high level overview of provisioning a cluster, checking if there's a DNS record. If there's a record, create the VM. Is the agent ready to is the VM ready to be prepped for Rancher? If it's not, run a setup playbook and then run the Rancher agent. The Rancher agent will install Kubernetes for you. And then there's the post config, which is install any bootstrap tools and enrolling it in Argo CD, add it to a load balancer. You're getting lost. So it's a lot of isolated steps that we have to do, and it just makes adding new it makes adding new clusters and new hosts just complicated. So yeah, pain points of Rancher version 1, a lot of manual everything, doing it the wrong way. When we need to patch security updates or just patch in general, it's the old school way of patching. You taint, you drain, yum update, and then you untaint. So we can automate that, but it just feels wrong. If we wanted to add like a worker node, another control plane node, it's that 8-step process that I talked about earlier. Bring up, pre-built that VM, run the agent. It made us not want to spin up new clusters, because it's just too much work. It was just not convenient to do. We also were on a network that wasn't DHCP, so we couldn't automatically get an IP. And we didn't have automation in our DNS. We're not allowed to. And another critical thing is at that time, we did not have access to our VMware's API. And slowly over time, each of our environments started getting environment drift, where this cluster was running a different version of external secrets or Ingress Nginx, stuff like that. And the production was running one version. Just overall a mess. So enough, we said. We evaluated what we were doing in version 1, and we just said, this is the wrong way of doing it. So something that we also struggled with is my team, we were on different levels of expertise with Kubernetes. So we have a team of 3, we have, I would say, probably a high level, mid level, and a low level of expertise at that time of Kubernetes. And something we needed to do was get everyone on at least the same baseline. And we had to level up. And so we looked at, my team looked at training courses that we can take. So we opted to look into the CKA and I guess for us, the CKA course on Code Cloud. And I'm proud to say that all three of us obtained the certification as of 2022. As a result of that, at least we can start speaking the same language. So terms like deployment, pod, service, ingress, at least we're familiar and we can talk about it. So that served as a really good baseline for us as a team. And I think that was the inspiration I had for this revamp to version 2 is I wanted to build this cluster with a team rather than it as an individual. And the inspiration is, in a nutshell, I wanted to create something like EKS on premise, something that we can just easily spin up with a click of a button. So this leads to planning for version 2 of Rancher. Our goal is resolve pain points of version 1. And the big feature to do that is to fully integrate into the vSphere cloud provider. Automate as much as we can, whether it's click button or using the Rancher API. I don't want to do old school ways of patching machines. We should be able to update our machines without having to log into systems. In the same way, we shouldn't have to pre-build VMs whenever we want to scale. It should scale for us. And ultimately, Rancher has the ability to provision and manage VMs and storage through the API. That was the key component to getting us this automation. And also reduce the environment drift by standardizing our bootstrap process. So a little bit about our version 2 infrastructure, just some terms. We are running Rancher 2.7 in K3s. And for all of our Kubernetes nodes, we're running Red Hat 8, Docker 20.10, and we're using RKE1. And we manage all of these by Ansible and Packer for deployment. Any downstream Kubernetes clusters will be managed by Rancher. And for the post setup, once you have your Kubernetes cluster going, we run this bootstrap process, which installs the following core tools that we use. So, persistent storage is very important in container land. So we wanted to tie into VMware, so we installed the vSphere CSI. So that allows us to use persistent storage for VMware. We wanted a way to not have to manually add things to a load balancer whenever we want to expose services to the public. We found a way to do that using Metal LB, and it's magical. That's all I can say. We don't have to add any special rules after provisioning. It just does it for us. The third item is external secrets. There's too many opinions of managing secrets in Kubernetes, and we use external secrets with AWS as our backend. And then, we don't like to be managed certificates, so we also use Cert Manager to automatically provision a certificate through Sectigo. We don't use Let's Encrypt. We use Sectigo since that's what the campus bought into. And last but not least, anytime we create a new cluster, we want that to automatically enroll in Argo CD. And Argo CD is a whole nother topic. But this is kind of what the infrastructure for version 2 looks like. And so the workflow for version 2, if you subtract the Booleans, it's just 3 steps, or really 2 steps. So it's just literally checking if templates or credentials exist. If they do, go into the GUI, select your templates, and just click create. There's none of this pre-build you have to do. None of, it's you don't have to know how to do it. You just use the templates that we built. So I personally think it's a lot simpler. But yeah. And I'd like to give a quick demo Let me reshare my screen. If I can find. All right. Everyone can see my screen. Remote folks, can you see my screen?
Yes.
Okay. So this is Rancher. Nothing. It's just a web page that we host on TW Rancher 1. Our first test cluster is here. You know, we are using it. It is live. We migrated from the old to the new cluster. So what I'm going to do is I'm just going to create a cluster in front of you guys. If this was version 1, I wouldn't be doing that because I'd take up the whole time. So all I have to do is create the cluster, give it a name, give my nodes a name, and then select one of the templates that I pre-populated. So I'm just going to do control plane. And then I want this to be worker, control plane, and etcd. And also here I can set, like, if I want 3 nodes, 2 nodes, 1 node, whatever you want. So that's one area of the template. And the other area of the template is the RKE template that I want to use. So we have a general template. What it's going to do is install Kubernetes 1.25.9, Calico. It's all pre-populated for you based off the input from the template. Yeah, so if Zoe wants a cluster, this is what I do. I just hit create. And then you'll see you can monitor the stats here. And then in VMware, you'll see that Rancher is cloning from a template. It's going to bring the VM up for me. And once it's ready, I have a cluster that I can give to Zoe. That's it. 3 steps, maybe 2. I don't know. It's going to take about maybe 5 minutes for it to spin up. So I'm just going to continue on the presentation. So give me a second. We'll get back to that. But yeah, that's I don't say that's how easy it is, but that is how easy it is. So I'll go back to the demo after it spins up, but I'm going to continue on with the slides. So now that we have the ability to spin up new clusters in version 2, what's our migration steps? So we are embracing GitOps, and in a nutshell, GitOps, the methodology of GitOps is you define your state in Git, and whatever you deploy reads Git to maintain that state. So if you don't make a change in Git, it's not going to apply it. So Git is the source of truth. It's very popular in Kubernetes right now. That's almost what everybody is using. And our tool of choice to implement that is a combination of GitHub, Helm, and Argo CD. And Argo CD is a whole other topic that we can talk about afterwards, or if you want to reach out to us afterwards, more than happy to discuss. But we're using something called an app of apps pattern. And basically what that allows us to do is we can allow automation of adding applications into Argo CD without knowing step by step. So each step of how to add it. And I'll give a snippet of what that looks like in a bit. And then once we deploy the new app using in Argo CD onto the new cluster, we just do a DNS swap. That's how we've been moving our applications from version 1 to version 2. And so in essence, this snippet of code right here is what is defined in one of our Git repositories. So in essence, basically a developer can just submit a PR following this format, and they would tell us where is the Helm chart. So the Helm chart in this case is in chartmuseum.library. It's under this path, in this revision. Okay, so you tell me where your Helm chart is. where's the values file that you want to deploy with the Helm chart? And in this case, a little bit of a special thing here. It says, look in this GitHub repository on main branch, or sorry, make this GitHub repository on the main branch as a variable, and then point to the values file in that GitHub repository and reference that to deploy with your Helm chart. So they would create a PR and we would review it. And if it looks good to us, we just merge it. And then that should deploy the developer's application. So they don't have to log into Argo CD to add an application. They don't have to wait for us to add it. They just have to wait for us to say, yeah, stamp of approval, go ahead and merge it. And any changes they make from here on, like let's say they want to increment the version number to 006, they just make the change here and then push it to Git, and then Argo CD detects like, oh, there's a new state to update to. It go ahead, it updates it to the next state. So that's the magic, I guess. Yeah. So where we are now, we migrated and decommissioned the test environment of version 1. We're almost done with the production environment of version 1. We reduced the provisioning steps from 8 complex and isolated tasks to 3 simplified tasks. You saw me just click 2 buttons. We also eliminated the need to like modify our load balancer statically to proxy traffic. So just no manual changes needed. And we also moved the cluster behind a private network and behind the enterprise firewall. So that just also makes us more secure. Devs can now add or manage the applications in Argo CD. And this project was really mostly beneficial for the sysadmins. We don't want to waste time. I mean, if Rancher can do the heavy lifting, we free up time to do other stuff, the fun stuff. And so far, we're pretty happy with it. Yeah, so the next steps we have is, now that our cluster is up and we're migrating our apps to the new cluster, the new environment, infrastructure-wise, centralized logging and monitoring for containers is important for us because now developers are struggling to get logs and we don't want to keep just doing dumps. So we're looking at Grafana and Loki for logging and Prometheus and Alert Manager for monitoring. The next step is also to harden Kubernetes. And right now we're just looking at policy control agents. Basically, these agents will check deployments or just resources running in Kubernetes and sees like you can set up a simple rule like is the image coming from Docker Hub? Is the deployment trying to use privilege mode? You can ban that with a policy control agent. And we'd love to look into Open Policy Agent. That's one of the more popular ones. And DR and backups of persistent storage. We're basically doing backups already, but I would like to look into a Kubernetes specific one. So Valero is what I like to look into. And applications wise, we have a very exciting project coming up from Kevin Clark and the services team. We want to explore with OpenFaaS. It's in a nutshell, Lambda on-premise, AWS Lambda on-premise, but not by AWS. So yeah, I think that's it. Let me see if my cluster is ready. Hey, it's done. Just like that. I have a cluster. And I don't know if that took 7 minutes. Yeah, 7 minutes. So yeah, I can say, here's Zoe, here's your cluster, go ahead and deploy your stuff. I guess another thing I can also show is like, if I needed to scale it, I remember how to do this. Like say I need it to scale and I want 3 nodes, I just bump it to 3 now. And then I save. And that will provision me. As you can see, it's creating the new nodes for me. And when those are online, it's ready. And then, using that Argo CD method that I showed, Zoe can proceed to create a PR and deploy our application. That's it for my presentation. If you'd like to learn more, here's our contacts. Yeah, opening up for questions if anyone has questions.
How do your devs feel about having to write Helm charts?
I think on the systems team, I think it's been embraced and they're used to it. So I think there's 2 developers there. On the services team, they're familiar to some extent. They've mostly been modifying the values file.
Okay.
So it's just a YAML file that you put your image tag or environment variables. Because of how they designed their containers, they designed it so that if you need to make a change, it's usually through an environment variable. So the Helm charts aren't generally touched, it's mostly the values file that are touched.
Okay. Great.
All right, going once, twice.
Any questions in the chat?
Oh, yeah, any questions in the chat? Nope, I think that's it. Okay.
Thank you.
Thank you all.
Robert, are you ready? Yeah, have you given it? Sorry. Anything.